All right, today we are going to use the skills that we learned from yesterday, and we are going to take those skills and estimate our numbers. So today our numbers aren't going to be quite as easy, but you're going to turn them into easy numbers. Give me an example of a reason why we estimate. Aiden, why do we estimate?
So you can get as close as possible.
Okay, without doing what?
Making mistakes.
Okay, or without... Kaden? Making a lot of work for ourselves. How many of you like things easier than harder? Okay, let's start with today's question. How can we estimate products? Think about this question during our lesson. So there is a store that needs to take in at least $15,000 every month to make sure that they have a profit. So if their store is open every single day in March and they make an average of $525 per day, will they make a profit? Could we figure this out using all the information we have? Okay. How many days are there in March? Can you see the calendar? 31. And how much money on the average do they make every day? So we could take that information and we could certainly figure it out. But let's estimate it instead. Let's make it simpler for us. So instead of this information, let's change it to make it something that's going to be easier to work with in our heads. Like what, Will?
100.
Say it again?
500.
500, okay. So $500 per day. And how many days are there? 31. Could we make that a number that's more workable? 30. So 500 times 30. Could we do that in our heads?
No.
Sure you can. Aiden.
Oh, it's 15,000 because it says it right there.
It is, but that didn't necessarily mean that's what we were going to get. If you figured out this problem using the regular numbers, you would not get exactly 15,000. We want to make sure that we get at least 15,000, or we're not going to make enough money to keep our store open, Aiden. So is this going to be enough?
No. Yeah.
Did we look at this number 500? Did we go up or did we estimate down?
Estimate down.
We estimated down. So actually, we make more than this per day. And actually, there are more days than 30 in a month. So are we safe to say that we make enough money to keep our store going? Mm-hmm. Definitely. So let's talk about what we're going to do to some numbers. Anytime you are estimating with a single digit, like a 1 through a 9, we can pretty much leave those alone. We don't have to change those. Although, when you're talking about a 9, it's just so darn close to 10. It makes it kind of hard. You want to change it to a 10, right? And that's okay, but typically, we can leave our single digits alone. However, anything larger than a single digit, we can round. So what would we change this problem to, Dathan? 60 times 6 equals 360. And if you did that problem the long way, you would find your answer to be very close to 360. Little harder. How about this problem? What would we do? What would we change these numbers to? Or wouldn't we? Aaron? Change this to a 700. I agree. Okay. Now remember, we can make this a basic math fact by ignoring all of our zeros. So we're left with the basic fact 7 times 2, which is what? 14. Now we can count up how many zeros we ignored and put them back in our answer. Sure, commas are nice, aren't they? Right, Alan? Little harder. So what could we do with these? Would we want to change all of them? Okay, what do you think, Sam? Okay. We could. Now, which two do you want to chunk together? Which two should you start with? 4 times, we have 3 numbers here. Which two do you want to start with? Like we did yesterday. 30 times 4, which is? Okay, so now we're left with 12 times 4. Can you do that in your head? Not many people can. I don't know if this was a good choice. Nope. Nope, it's not. I don't know. I don't know if that was a good choice. I don't think we should have changed 27 to 30. I think there's a better number. Cole? Like that? I don't think so either. I don't like that either. I think we need to look at this number. I don't think 30 was a good choice. What could have we changed it to, Darius? 25. Oh, yeah. Because now look. Now we have 25 times 4, which is 100. 100 times, well, we had this over here changed to 40. 100 times 40 is 4,000. Oh, yeah. See, sometimes if your number is really close to 25, 25s are good numbers to work with, aren't they? We know how to easily count by 25s because we're so familiar with the quarter in money. Sky, what do you think? Good. Excellent. Aaron? Basic math fact, 4 times 7. Are you guys finding in the first 2 days of the multiplication unit how important it is to learn your math facts? Yeah. I don't know if math bingo is really doing the trick. I think we need to focus not so much on the game, but on the actual facts, don't you think? Yeah. Nobody knows 7 times 4? We are in trouble. Aaron, you want to try it? How many zeros do I need to add? 2. So that's not 28,000, that's 2,800. Or another way to say that is 2,800. Good work. Let's do one more up here. Oh, no, we did run out. Okay, now I'd like you guys to grab your iPads and go to a notebook or an Explain Everything file. Our first example is the top one right here. Everybody needs to write this down exactly the way you see it. 13 times 40 times 12. Now you can change all or some of those numbers, and then you can chunk them and find the compatible ones to work with. He's been gone for a few days. Who would like to share their example with me? Let's see. I need a girl. I have some. Kaden, can you tell me, did you change any of your numbers? Became a? Did you do anything with the 40? How about the 12? Okay. What 2 numbers did you start by chunking together? The 2 tens were? So you have 100 times 40 equals 4,000. Correct. Check your answer with Caden's. You may have chunked numbers differently. Maybe you chose the 40 and the 20, excuse me, the 40 and the 10 together. You're still going to get the same answer. Okay, new screen. Second problem, hard to read, it's a little bit lighter. 4 times 26 times 8. then go to a different page. Go to a notebook page. Go to something different. I hope you guys were listening earlier in the lesson. This is a problem that's perfect for what we talked about. This problem actually shouldn't take you very long. Sam Woolman, how many numbers did you change?
One.
Only one. Which one was it?
26 to a 25.
Absolutely. You could have changed it to a 30, but that was going to be pretty tough to do the rest of the problem in your head. So now 4 times 25 is? 100 times 8, Sam?
800.
There's your answer. Thumb in the air high if you got that one right. If you change this to a 30, then you would have ended up with 24 times 4 or 12 times 8. Both of those are ones you can't do in your head. So anytime that happens, you probably need to look back and think, oh, I bet I could have done something different. Next problem. Erase and go to the next one.
There's another way to do that one.
How would that be?
You make the 26 20.
But that's too far away. But then we're not going to be very accurate. 26 is closer to 30 than it is to 20. We would never change it to 20. It's just like rounding. We're going to want to bring it to the nearest multiple of 10. And 20 isn't closer. Natasha, are you good at multiplying by 15s in your head? I wouldn't change that to a 15 then. Careful, please, with that. Dathan, what'd you do?
I changed the 18 and 19. I changed them both to 20. Then I took 20 times 20, and I got to 400. And then I took 4 times 5 and got 20, and then I added the 3 zeros and made 20,000.
Yep. The basic math fact left was 4 times 5, which is 20. So you write in the 20, and then you add in your leftover zeros. See what you did wrong? Yep, you just forgot a 0. Okay,